Hello, today we are doing Chapter 5, Section 7. Our essential question is, how can you graph a system of linear inequalities? Well, let's first figure out how can we tell if something is a solution. Well, a system means that you're going to have more than one. And linear inequalities is what we just talked about in our last section. So here we have two linear inequalities. Because we have more than one, it's a system. Well, they're giving me an ordered pair, which of course is an x and a y. So I'm going to plug those into both equations and see if I get a true statement or a false. Whoops. So I'm going to plug in 3 for x, 5 in for y. Do it for the first one, and I get 5 is less than 6. Well, that's true. So I'm going to move on to the second inequality, which is y is greater than or equal to x plus 1. Put in 3 for x, 5 for y, and I get 5 is greater than or equal to 4. Well, because it worked out for both of them, I'm going to go, yeah, that is a solution. Well, let's see if negative 2, 0 is also a solution. So you go to your first inequality, and I'm going to plug in negative 2 for x, 0 in for y. Well, I get 0 is less than negative 4, which is not true. 0 is bigger. So that's a big fat no. That's why there's an x there and a line through that inequality. Even though the second one worked out, it's not true for both of them, so it is not a solution of the system. So on this one, I put y is greater than, or y is less than 5. Well, right here is my y value, it's 5. And if I plug that in, I'm going to get 5 is less than 5. Well, it's close. It's equal to, but it's not less than. So I can already say that one is going to be a no. Go ahead and hit pause. Try number 2 on your own. All right. So how can you tell from a graph whether something is a solution? What you're going to do is you're going to graph both inequalities, and you're going to graph them on the same coordinate plane. And where those graphs overlap is actually your solution. So on this one right here, the red, we're shading above. And right here, I'm shading below in blue. And where the red and the blue overlap, right here, just kind of marking that so you can see it. It's actually kind of a purple color. That's where my real solution is. That's where the graphs overlap. That's where the shading overlaps. That's where my solution is. So let's go ahead and do an example. So I've got 2 inequalities. What I'm going to do is I'm going to graph both of them. The first one, y is less than or equal to 3. It's going to be a horizontal line, and it would be shaded down below. And then on my next one, I have y is greater than x plus 2. It's going to be a dotted line. My y-intercept is 2. My slope is 1. And it's greater than, so I'm shading above. All of this right here, that's kind of purple, is my solution. So negative 3, 1 is a solution. Negative 2, 2 is a solution. Anything on this line up to this point is a solution. But anything that is not shaded purple is not a solution. The solution is the purple shaded region. So what you do, just graph each of them independently, and where the shading overlaps is your solution. What I would suggest you do is do your first shading really, really light in pencil, and your second shading really light as well. and then you shade really dark where they two overlap. So on this one, we already have things graphed for you. And if you notice, on this first one, if I subtract 2x, my y-intercept is going to be -1. My slope is -2. It's less than, so I'm shading lower. Equation 2 is in red. I subtract 2x from both sides. My y-intercept is 3. My slope is -2. And I would be shading above because it's greater. Well, there's no points where the graphs overlap each other. So this one would be a no solution. You're always looking for where they overlap each other. And if they don't overlap, it's a no solution. All right. I would suggest getting some graph paper or a ruler, trying these on your own, and then check yourself. Also, I would also hit pause. So on this first one, they don't intersect, so that would be a no solution. The darker blue is where they intersect. That would be your final solution. So on my equation number 1, which is dotted, I'm shading above. My equation number 2, I'm shading above. It's going to be right here. So here's my equation number 1. I'm going to be for equation number 1, I'm shading down lower. Here's my equation number 2, I'm running my mouse along it. And that one is greater than, so I'm shading above. Where it's dark blue is your final solution. So I want to write a system of linear inequalities. So on this one, they're giving me the graph, and I need to come up with 2 inequalities. Well, what I notice right away is I've got a solid line and it's horizontal. So if something is horizontal, I know it's y equals. So my boundary line is y equals -2. And it's shaded above, so that's greater, so I would use a greater than or equal to. So my first one is y is greater than or equal to -2. For my next one, my boundary line, my y-intercept is 0, because that's where it's crossing, and my slope is 1. So it would be 1x plus 0. So that's where they come up with that y equals x. It's also dashed, so there's not going to be any equal sign, and I'm shading lower, so it's y is less than x. Let's go ahead and do another one. On this one, let's do the vertical line first because that'll be the easiest. So it's not going to be y equals. My border line is x equals 3. Now I need to figure out what type of inequality. Well, it's being shaded to the left, which is less than. So it'd be, and it's a solid line, so x is less than or equal to 3. Now, let's go ahead and get our border line for this dotted line. Well, my y-intercept is -1, and my slope is looks like my rise over run is 2/3, so y equals 2/3x minus 1. And what I notice on that is it's dotted, so no equal to sign, and it's shaded above, so that would be a greater than. So y is greater than 2/3 x minus 1. So there are my system of inequalities. Why don't you hit pause and try these two on your own. Really look for where those y-intercepts are and what your slopes are. So on this first one, your y-intercept is 2 and your slope is -1. It's dotted and it's shaded below, so it's going to be a less than. We also have a vertical line, so it's going to be x shaded to the left, less than 3. On number 7, my y-intercept is 1. My slope is -1/2, down 1, right 2. And it's being shaded above, and it's solid, so it's going to be greater than or equal to. On my second line, my y-intercept is -3. My slope is 2/1. So, and it's going to be shaded below because it's going lower. So 2x minus 3. Y is less than or equal to 2x minus 3. All right, let's do a word problem. You have at most 8 hours to spend at the mall and at the beach. You want to spend at least 2 hours at the mall and more than 4 hours at the beach. We want to write and graph a system that represents the situation. And then they're asking us, how much time can you spend at each location? Well, I would look at my graph and see where my shaded region is. So we're going to write a system of equations and graph it. So there is my plan. So x is going to be the number of hours at the mall, and y is the number of hours at the beach. If you wanted to, you could have used m and b. It doesn't really matter. Well, I have at most 8 hours to spend. So the number of hours at the mall and at the beach has to be less than or equal to 8. I can't spend more than 8 hours. And I want to spend at least 2 hours at the mall. So x has to be greater than or equal to 2. And more than 4 hours at the beach. So y has to be greater than 4. So let's go ahead and graph this. And again, I might use a graphing app like Desmos.com to graph that. Here's my x plus y is less than or equal to 8, and it's going to be shaded down below. X is greater than or equal to 2. That's my vertical line, and it's shaded to the right. And y is greater than 4. It's going to be a dotted line, and that's going to be shaded up. So where all the shading overlaps is that little triangle. So I just get any ordered pair within that shaded region. They're giving you one right there of 2.5, 5, which would be right about there. I might have chosen 3, 5. It's on the line, but anything within that region is going to be fine. You could have probably picked 3, 4.5. So there's going to be more than one answer. And you can always check your answers by substituting them back in. So on this one, we want to name an ordered pair that is a solution and name an ordered pair that is not a solution. Well, there's going to be more than one answer here. But a solution, 0, 0. That's an easy one. It's in the shaded region. So any ordered pair that is in the shaded region. An example of a non-solution would be 3, 3. Right 3, up 3. That point right there, it's out of the shaded region. That would be a no solution. All right, hope you enjoyed.